Since we're getting into some of the heavy calculations, I wanted to make one more video for you showing how to do the paired sample t-test. I also would encourage you to look at the end of every chapter where it says how it works. They usually walk through one of the statistical tests kind of in a summarized form, and I think that's pretty helpful. So I am doing problem number 18 in chapter 10. If you want to look it up, you can see the data values. It's basically before and after they watch a funny video clip and they're supposed to figure out what their mood is. So I'm going to take you through the steps here just to make sure you get another example. I have this done in Excel. If you just want to write it down and use a calculator, you can. But the sooner you can learn how to use some of these things in Excel, the better. So I would just suggest that you pause the video if you want to split the screen or whatever to help you figure it out. Okay, so first of all, we find the difference between the scores. Okay, so anytime you're doing a formula in Excel, you type in equals, and we're going to subtract the second score minus the first score to see what the difference, because like this went down, so we wanted to show a -5. So that's the first thing. Here's the reason why I would suggest use Excel. If you grab this corner and drag it down, then all your formulas are entered for you. You don't have to keep retyping them. Okay, and then this says D minus M. Well, D is what we just found, the difference. M is the mean difference. Okay, so we are finding the mean difference between those two. That mean means average. So we're finding the average. So I typed in equals average of these values. And so that tells you how much they differ on average. So basically we're subtracting -2.41667 from each of these scores. So you can do this and then do minus that -2.41667, or to enter that cell, you have to put a $sign to make sure it stays that number. But you can just subtract each of those individually and drag it down if you want. So this is all of those differences from the mean difference. So we're kind of we're figuring out a standard deviation of the differences, basically. And so the next process is to square this number, multiply it by itself. Again, if you drag this corner, you have all of those, and then we're going to need the sum of those squares. So again, Excel is easy for finding. You can either enter the E3 colon E14 or just drag it down. So when I add up all those squares, like I'm finding standard deviation, that's what I get. Okay, so we're going to do this problem. We're not going to go through all the steps of the test, but we're going to do the t-value and make a decision for a one-tailed and a two-tailed test. So first of all, standard deviation of the sample. And I'm reading down here in the formulas. It says the sum of the squareds divided by n minus 1. So the sum of the squareds is this value right here. So I'm going to type equals. It's this value divided by n minus 1. And you can just count how many there are. 14 minus 3 is 11. Add 1 is 12. So it means our n minus 1 would be 11. So if I just take that sum divided by 11, and then I can take the square root of that number, and that gives me my standard deviation of the sample. Some people have also figured out that you can do the standard deviation of the sample formula, but you got to make sure you do this column if you're doing that and not the squared. A few of you have done it with the squared and messed it up. So those are the same either way. That's my standard deviation. Standard error is the standard deviation divided by the square root of n. So standard deviation, we just found it, divided by square root of n. N is the number of values, so there's 12. So there's my standard error. And now the t statistic, it says for a single sample t, it's the same for a paired sample t. The difference is for a paired sample t, we're assuming that mu sub n is 0. We're assuming there's no difference in the means. That's part of our assumptions. So to calculate this, I'm going to take the mean difference, which we called m, minus 0. I'm just going to put that 0 in there so I know it's there, divided by the standard error that we just found. And so there's my t statistic. And so it says a one-tailed, we're going to do this test, a one-tailed test at 5% that improves mood. So we're setting this up. We're going to assume, and I like to look at the research hypothesis, we're assuming that the mood is higher after watching the video. So that means if there's a null hypothesis, it would be that the first is greater than or equal to. So everything else. So I go over to my t-test table, which is B2, and I have the degrees of freedom are n minus 1, so the number of samples, so I have 12, so I'm looking at 11. So my t value at 5% would be 1.796. Okay, and so the critical value. So the decision would not, we'd either use positive or negative 1.96. We're trying to see if the scores were higher. They're actually lower. So this actually would be fail to reject because it would not be in our critical region. This t is really big, but it's in a negative value. Now, the second part of this question says, just do a two-tailed test. So a two-tailed test is a little bit easier because you're either seeing, are the means the same or are they not the same? We're not trying to figure out, do we think one's bigger or one's smaller? So for the two-tailed test, you go over here and that's at 5% with 11 degrees of freedom. That critical value is 2.201. So that means I'm looking to see am I bigger than 2.201 or smaller than negative 2.201. It's trying to make me do this as a formula. If you get crazy stuff in Excel errors, you can usually put a colon or an apostrophe in front of that, and it'll turn numbers into text for you. So am I outside of that value with this t statistic? Yeah, well, it's really, really negative. It's really small. So if I were looking at a curve, this would be way to the left. So this would be rejected. So we would reject basically we would say that the means are statistically not the same. Okay. So I want to show you before I finish this video. There's a couple other places on here. So this is the single sample t-test, and there's an Excel sheet for you, and then the video walks you through it. And then problem 29 in the book, I started putting this in last year. We used to only use a program that you have to log into the Goshen College computers through your computer. It's really not very easy to do. It's called Minitab. And so I'm switching everything to Excel. You might hear me say I want to switch it to Excel. That's because I made the video last year. But I take you through the steps here. And then as we go on, we will have you'll see next week there's a lab that you're going to be doing several different things on Excel. But I made a template for that so that you basically can just plug your numbers in there. So this is good practice to get used to doing that. So to give you a little extra help. Make sure that you're using the review at the end of the chapters that have all those steps. You might just kind of make a file of your different processes.